Hey, welcome to Math 8. This is Unit 4, Lesson 13. As we see right here, solving systems of equations. Now, my screen's going to look just a little bit different than yours because I get to see all of the questions at once. But don't stress too much about that. As we look at this, the first thing we need to do is write an equation for the black line that's shown, and then we're going to write an equation for the blue line that's shown. Need to have both equations because what we're going to do is actually solve for that system of equations. And so what I want to look at on here is I want to be able to actually come over here and let's go ahead and write on here. Let's talk about the black line. First off, with that black line, what we're after with this, a couple of things. We need to be able to identify the slope, and then we need to identify the b coordinate of the y-intercept, or the y coordinate of the y-intercept, which will be b. So with this one, as we look at our slope, we can look at a couple of nice integer points and how those integer points are changing. And what I'm seeing as I'm drawing these is I'm actually seeing that I'm looking at my intervals. They're intervals of 1, so it's 1, 2, 3, 4, 5. So I know that I'm actually rising by 1, 2, 3 and running by 1. So rise of 3, run of 1. And I see I'm crossing the y-axis at 0, 2. So if that's at 0, 2, then my b term would be 2, making the black line y is equal to m, slope, times x, plus positive 2. So there's my black line. Let's talk about the blue line. Doing the same thing, finding the slope and the y-intercept. I see that nice, simple interval points falling through in this pattern, dropping 3 or down negative 3. Run of positive 1. I see my slope is just pretty much the opposite. It's negative 3. So my blue line is y equals negative 3 for my slope times x. And my y-intercept, though, is up here at positive 8, so plus 8. And now that I have those two equations, I have the ability to be able to actually talk about the system of equations and talk about their solution. Now, obviously, there is a solution here because what I can see with this is I can see that the two lines intersect at one single point. And you'll see that one single point becomes very important because that one single point will tell us that these two equations are equal at that exact same spot. So now what we want to pay attention to on this is how can I prove that? Well, the first thing that I can do when I look at my questions is it says right here, use x as your variable, use y as your variable. So I want to make sure that when you put in your equation right here, please notice that they already have y equals. Don't put in y equals again. Put in just the other expression that shows that where we say that y equals from the black line, 3x plus 2. And then when we go and we put this in for the blue line, talking about part B, we have y equals negative 3 times x plus 8. Then we get to part C and it says describe how to find the solution to the corresponding system by looking at the graph. Well, if you're going to look at the graph, what are you looking for? Okay, what are you looking for to make sure that we know when the system has a common solution? Well, in this case, we know the lines intersected once, so what we're looking for is that one single point. And make sure you tell me why we want that point. Part D, when we look at part D, describe how to find the solution to the system equation using the equations. Well, I'm just going to show you real quick what we're going to do with that. We had two equations. We had negative 3 times x plus 8. And we had y equals 3 times x plus, I think it was 2. I'm just going to verify so I don't write the wrong thing. Good. So plus 2. Now, how can I know? Well, what I'm asking from this is I'm saying at what point are these two equations that are on the same coordinate plane, at what point are they equal? And the fact is they are equal right here. They both equal y. So by that logic, if they both equal the same outcome, they both equal the exact same y, then that means then the expression negative 3 times x plus 8 must be equal to 3 times x plus 2 because they both share the exact same value. It'd kind of be like saying this one right here is equal to y and this one right here is equal to y. And rather than putting y right in the middle, I can just put an equal sign and say that these two are equal to each other. And then my next process is simply to solve for x, and then substitute and solve for y. And there I am giving you the answer for part D. You're welcome. Let's talk about the next question. It says the solution to the system of equations is 5, -19. Choose two equations that might make up the system. So what are we looking for? If we have to choose two equations that might make up the system, then we're saying choose two equations that are true when x, y equals 5 and -19. Okay, we have to make sure that they're true. So there could be two of them in here, two equations that will have the solution 5, -19 that will make them true. You need to choose two of them. But understand that there could be multiple. There could be three, because a system of equations is two or more graphs that are on the same plane that have a true statement or a true outcome based on the solution. So the next part of it, or the next question, the next two questions is all about solving the system of equations. And so when we're solving the system of equations, write your answer in the format of x, y. So with no spaces, that means when you write your answer right here, I need an ordered pair right here. And when we talk about putting that ordered pair in there, again, remember, both equations equal the exact same thing. So that means 4 times x minus 3 has to be equal to -2 times x plus 9. So when you solve this, solve for x. Once you know what x equals, substitute back in for x and get y. And make sure that you get the same value on both of them. Same thing on the next equation. Right here, they're both equal to y. So that means that 5/4 of x minus 2 is equal to -1/4 of x plus 19. Now, I do want to bring something up in these two equations just for a bit of review to help us remember something. We talked about how can I find out if I have one, none, or infinitely many solutions. Remember that when we're comparing the coefficients of x, or the variable terms will help us to know if I have one, none, or infinitely many solutions. These variable terms in this first part of the problem are different, which is a dead giveaway for one solution. There will be one solution. Same thing in the second part of the equations, where you see that the slopes are different. Again, this is it's a guaranteed there is one solution that's available for us. So there's only one way that you will find a solution that will make both of those equations exactly equal. Again, the second part of that, no spaces in your answer. And then finally, part A, with this one, you need to solve the equation two different ways. First off, distributive property. Okay, type your answer below. And then the second way, without distributive property. So with distributive property means on this first one, I need to see 15 times x minus 45. All that divided by 5 is equal to 6 times x minus 9. And then you finish solving it. Little bit of a hint. Start right here and maybe think about it like this. 15 times x divided by 5 minus 45 divided by 5. And I think that you'll see something a little bit different. It'll be a lot easier than trying to multiply both sides by 5. The next one says without using the distributive property, meaning that you are not allowed to use the distributive property when you do this again for part B. And so here's what I would suggest to you. I would recommend that you come over here, how it says divide by 5, put that 5 right underneath of the 15 and see what happens. It tends to make it a little easier for me to look at my screen or to look at my paper and my work when I see those are together. I can actually just work through that. And then what I'll get is 3 times the difference of x and 3 is equal to 3 times the difference of 2x and 3. And then from there, again, you still are not allowed to use the distributive property, but take a look at the coefficients. What if I divide both sides by that coefficient? I can see it go away. Check your solution though, make sure it's right. In your answer, do not put x equals, just put this value right here. I know it's a little backwards from what we've done, but that's the homework for you. Please let me know if you have any questions. Thanks for hanging in there. Have a great day.